so welcome back to my channel, and today the topic is systems of equations, and I hope you're all having a wonderful day, and let's just get started with today's topic. Okay, so the first out of the two ways that you can solve system of equations is elimination, and this can be very easy once you get the hang of it. Okay, so this is our first question. Is 10x minus 2y equals 44 and negative 2x minus 9y equals 10. So what you want to do is find the lowest number that you can multiply either of the equations with to either get rid of x or y. And in this case, I multiplied the bottom equation by 5 because that would help me get rid of the 10x, because when I multiplied that, it would give me negative 10x, which would allow me to cross out the x and solve for the y. And then when I get the y, I could easily just plug it in and get the x. So now that I multiplied that, I just got rid of the 10x like I said, and then I combined my like terms, so the y and the y in the numbers. Then I just divided that by negative 47 on both sides, and I ended up getting y equals negative 2. Okay, so now that I know what my y equals, I can easily just plug it into an original equation and just multiply that out, and yeah, I just distributed the 2 into the parentheses, and I just found out what x was, and since it's an ordered pair, I just put it together, and that was my answer. Okay, so x is equal to 4, and so for my little parentheses, it's just going to be, the answer is going to be 4 comma negative 2, and it's an ordered pair, so make sure you put it just like that, and that means it has one solution. Okay, now for number 2, still elimination. This is the second problem. 5x minus 4y equals 34 and negative x plus 8y equals 22. Same thing, I want to get rid of the y this time though, so I multiplied the top equation by 2, and that gave me 10x minus 8y equals 68. And so now all I have to do is basically cancel out. So 10x minus x is 9x, cancel out the y's, and that gives me 90. Yes, 90. And then when you divide by 9 on both sides, you end up with x equals 10. Okay, so now we're just going to repeat the same steps. So I'm just going to plug in x into one of the original equations that they gave to me. And so I don't remember what equation I chose, but I chose one of them. And so I distributed the negative, because that's a negative 1 in front of it, to the 10, and then the 8y, and then the 22. I added 10 to both sides, so 8y equals 32, divide by 8 on both sides, and y equals 4. Then for my ordered pairs, why should I put that to the calculator? Oh my gosh. But for the ordered pair, it would be 10 comma 4, and that's my answer. So that equation, that problem, has one solution. Okay, so this is the last example of elimination I will be doing. So this is the third one. Negative 3x minus 7y equals 18. 9x plus 2y equals 3. And I just chose 3 so I could get rid of the x. It would have been harder till I get rid of the y, because I have to multiply the top by 2 and then the bottom by 7 if I want to get rid of that. So the x is easier to do. Okay, so now I just moved the top equation multiplied to the bottom, and I just basically start canceling out. So you can cancel out the 9x, because 9x minus 9x is 0. And then get my y and then the number. Then I divided by 19 on both sides, because we want y by itself. Not negative y, but just y. Okay, so now I divided because I didn't know what that was. I didn't even think it was going to divide, but it did. But yeah, now I know what y is. And yeah, whichever one you choose to get rid of, you get the other one. So if you choose to get rid of x, you get y. If you choose to get rid of y, you get x. So yeah. Now I just plugged into one of the equations to get x. And yeah. So negative 3x plus 21, so you subtract 21 from both sides. And then negative 21 plus 18 is negative 3, so negative 3x equals negative 3. Divide both sides by negative 3, and I get x equals 1. So my order pair is going to be 1, comma, negative 3, and that is one solution, and it works. You can plug it in to check. You can always plug in your stuff, like whenever you get the order pair, you can always just plug it into both equations. I'm talking too fast. Into both equations to make sure you're correct. Okay, so this is the first problem for substitution. This is another way. All you have to do is just plug in stuff. So all I did was rewrite the second equation because it was backwards. And so y equals 10x plus 8. So all I have to do is just plug that into the first equation. Don't plug it into the one that you rewrote because it will give you infinitely many solutions because it would equal itself. So plug into the other one, okay? So the first one in this case. And so I just put into parentheses so I wouldn't confuse myself. So I replaced the equation for y into y, and I just solved away. And 9x equals negative 18, and when you divide by 9 on both sides, you get negative 2 for x. And then now you can plug it into either equation that appears easier for you. I know I said you could choose either equation, but now that I look back, the way I chose to solve it was kind of stupid because it would have been way easier for me to just plug it into the y equals equations because I am looking for y, so I could just plug in x and just add it on one side. But I chose a more complicated way because, yeah, I'm dramatic. So, yeah, I'm just solving for y with the first equation, I believe. And it wasn't hard, but it was just more work, I guess. So yeah, y equals negative 12, and for my order pair, I would get negative 2, negative 12. Yeah, that's my answer. And if I had done it wrong, it would be infinitely many solutions, and it's not. Okay, on to the second problem for substitution. And I have x equals negative y minus 9 and 6x minus 5y equals 1. And they made it easy by just giving me straight up what x equals. So all I have to do is plug it into 6x. So just plug in the equation for x because that's what x equals. And then I have to distribute 6 to everything that's inside parentheses. So 6 times negative y is negative 6y, and 6 times negative 9 is negative 54, minus 5y equals 1. And I just combined like terms, and I ended up with negative 11y minus 54 equals 1. Then I just added 54 to both sides, so negative 11y could be by itself. Then divide by negative 11 on both sides so I could have y all by itself. And I ended up with negative 5, I believe. Yeah, so now I know what y equals, so it would just be easy for me to plug into the first equation to get what x equals. Did I do that? Oh my gosh, let's find out. I think I did that. Yes, I was really smart because then it just takes like one step. So x equals positive 5 because negative times negative gives you a positive. Minus 9, so x equals negative 4. This is what I was talking about in the previous one. It will just be so much easier to just do this. And so my answer is negative 4 and negative 5. And that's it. That's the answer. One solution. You can plug it in to check if it's correct. Okay, so this is the last problem for substitution. So we have 3x plus 8y equals 2 and y equals negative 2x minus 3. So plugging y into the first equation, please do not plug it back into the second one. Like, please don't plug in y into the y equals equation. It's just, no, just don't. Please don't do it. Just, you have to plug into the first one. So you plug that in, then you distribute the 8 because it's being multiplied by it, because 8y is 8 multiplying by y, so 8 times y. So you have to distribute the 8 into parentheses. And then you end up with See where am I at? So I'm just combining my terms right now, and divide by negative 13 on both sides, and you get x equals negative 2. And now I can plug it into the y equals equation because now I know what x equals and I'm trying to find y. So let's see, that's the equation I used. Yes, so y equals negative 2 multiplied by the x, which I now know what it is. So y equals 4 minus 3. And now y equals 1. So my order here is negative 2, comma 1. That is one solution, and that's where they intersect. And you can plug that into your calculator into both equations to see if it works out. Okay, so now I'm going to show you guys how to graph this in your graphing calculator. So I'm pretty sure I have the TI-84 calculator or something like that. So by graphing, you can find out how many solutions there are on the graph, because you can like physically like see on the graph, and you can like check your answers and stuff like that in the table, and it just makes life really easy. So all I did was put these equations into y equals mx plus b form so I could put into my calculator, and then I grabbed that, and you can see that they only intersect one time, and that proves the point of it helps prove my answer. So in this clip, all I did was go to second calc, and I clicked on intersect, and I kind of just like messed around with it, and it gave me the answer that I got originally. So that's another way to prove it. Okay, so now we're just gonna round up with 3 questions, and the first one I will be using elimination, and the question is how many solutions does each equation have, I guess. So I multiplied the top by negative 2 so I could get rid of the x, but you can see as I multiply through that I am going to eventually get rid of every single thing, because the answer is going to be infinitely many solutions, because 0 will always equal 0. So I made a mistake in the 2x because the negative times the negative is a positive. So now I cancel everything out, and I get 0 equals 0. And like I said, infinitely many solutions, and it's the same line. Okay, so as you guys can see, I just rewrote both of the equations in y equals mx plus b form, so it'll be easy for me to put into my calculator, which is the only way to put into my calculator. And they ended up being the same equation, which is quite obvious because it's infinitely many solutions, which means they're both going to have the same x and y's forever, because it's the same solution. I mean the same equation, so yeah. I just went through the table to show you guys that. Okay, so on to number 2. I also used elimination to solve this one. I multiplied the top equation by 2 so I can get rid of the y and solve for x. So multiplying through, I ended up in negative 2x plus 2y. Yeah, I made a mistake. Plus 2y equals negative 12. And then when you cancel through, you end up with x, you cancel out the y because 2y minus 2y is 0, equals negative 2. So now that I know what x is, I can plug into one of the equations and get what y is. Because I distributed, and that y kind of confuses you, so don't put it there, because you might want to subtract the y and end up with 0, and it's just going to be confusing, so just don't put it there. So y equals negative 8, and I ended up with one solution. And here I rewrote the equations into y equals mx plus b, so I can also put into my calculator and show you guys when I graph it. So all you want to do when you're trying to solve or put it into y equals mx plus b, all you have to do is get y on one side by itself, and yeah, just make sure it's just y all by itself. So now that I graphed it, I tried to do the intersection thing, and I mean, it wasn't like, I don't know, I feel like if you get your answer and you try to like confirm it, I mean, I guess it worked, but like not really, because I was struggling to get like an exact like spot on answer, and I just didn't get that. So I'm just like, okay, let's just leave this for the quadratics and like not do this again. So I went to the table, and yeah, I confirmed that my answer was right. Okay, so for the last problem, I decided I would try to do substitution because I've been doing a lot of eliminations, and I'm gonna show you guys that you can also do substitution if that works out really easy for you. So I decided to substitute the first problem, and so I just got y by itself by adding 4x to both sides and dividing everything by 5. And so I know what y equals, and I just plug that into the second equation so I could get x by itself. Again, so I cancel out the x's because 8x minus 8x equals 0. And I got negative 14 equals negative 15. And that's no solution because that's never going to be possible. Also, if you like to do elimination over substitution, I decided to work out this problem for you just so you can see that it works both ways, and I came up with the same answer, no solution. Calculator is really going to be your best friend, but I plugged this into my calculator, and obviously it has the same slope and different y-intercepts, so that means it's going to keep going up the same way and they're never going to touch because of the same slope. And so I went into the table anytime now. I went into my table, and yeah, they're really close to touching, but they're never going to because of the same slope. And yeah, thank you guys so very much for watching to the very end, and I hope you guys really found this video helpful and learned some new tips and tricks for solving system equations. Feel free to leave a like, comment, and subscribe. Turn on your post notifications so you never miss out on another video, and I will see you guys in the next one. Bye guys.